Hello everyone, in this video I will be talking about some common problems that you have in homework number 1. So starting with the first one, the ER diagram. Most of you did well for this one, but one common problem is that in the ER diagram, the lines that connect the relationships to the entities are actually showing us the foreign keys. So with this line, I know that I store some foreign key inside in category that is going to reference the entity's primary key. So for category, it's CID. So the common mistake was some people were including these foreign keys explicitly. So in the ER diagram, we do not show these foreign keys explicitly. For relationships, we can include additional attributes, but the problem is we should not show these foreign keys separately. These lines are already talking about such foreign keys. And while grading the questions, we are focused on some important aspects. So in this question, this was the important part. If you included the foreign keys explicitly, you get partial grade. Otherwise, you get full grade from that question. In question number 2, the common mistake is, it's actually not that common, but sometimes people confuse these signs. So if I have the open side towards up, this means or. If I have the open side downwards, this means and. And according to which one you use, this is going to differ a lot. So if you say CNAME is equal to diary or vegetable, it is going to return if it is diary or if it is vegetable. But if you mistakenly say that it is equal to diary and vegetable, this is going to return nothing, because we are looking at just one attribute, right? We have some category table with different attributes, and CNAME is just one attribute, and this attribute cannot be equal to diary and vegetable at the same time. So it should be either one of them, or it could be some other CNAME, some other category name. But the problem is that if you say and, this is going to return nothing, and it will be a mistake. So using this is a big mistake for this question. So therefore you did not get any grades, because that was some important aspect for this question. For question number 3, almost all people did it correctly. For question number 4, we are saying that okay, there are 2 different suppliers, Barilla and Phyllis, and these are selling some products, and we would like to find out the products that are sold both by Barilla and Phyllis. For example, these are for pasta, right? And there could be different kinds of pasta. So these different kinds of pasta are going to be our products actually. And some of these products are supplied by Barilla, some of them are supplied by Phyllis, and some of them are supplied by both these suppliers. One common mistake was people were saying that okay, I'm going to select from supplier for S-name equal to Barilla and S-name equal to Phyllis. So this is going to be a mistake, very similar to question number 2, because we know that for the same attribute, it cannot be equal to 2 different things at the same time. So it is either Barilla or Phyllis, or it can be some other supplier. So using this and sign here is going to be a mistake. So I'm talking about people that are not using the this is not the union, so I have some trouble remembering the name of the sign, sorry for that. So I will just come to there. Kesişim in Turkish. If I remember it, I will say the English name as well. So for this part, I'm just talking about for now. Some people are selecting from supplier, where S name is Barilla and Phyllis. And some people are also using the OR sign, and they are joining with the sold by table, and then they are also joining with the product table and getting the P name. So the problem is that in here, in this aspect, without using this set operation, we have some Barilla products and we have some Phyllis products. So these are in terms of products. And if you say, okay, I either get the supplier Barilla or Phyllis, then you are also getting these differences. What we are interested in actually is this area, the common part. So in order to get that, we need this set operation. So if let me just quickly look at that. Otherwise it will kind of get nonsense. Okay, intersection. Very easy word. So we need the intersection operation, set operation. Otherwise there is also some other solution. A couple of people did that. You just get two different suppliers. Remember, like a Cartesian product, and on one side you choose Barilla, on one side you choose Phyllis, and you try to make the products the same, which is not very conventional way of doing it. So to solve it, the important part was using the set intersection. Otherwise, with just using the or and sign and making a selection and the joins, it is not enough. So again, since this was the important part to get full grade, you need to include that. So question number 5, most of the people did it correct. Question number 6 was actually very easy, but some people taught it in a different way. So we are talking about the products whose expiration date is today. So in our table for the inside the sold by relationship, for the products that are sold by some supplier, we are keeping the expiration date, and this is some dates, and this date should be equal to today's date. You can also write today instead of writing some date. You can write it as if it is a function, so get dates, for example. All of them, we accept them. But the problem is sometimes people thought that we are trying to find the maximum or the minimum of the expiration date. But it doesn't make sense, because in our table, some of the products could be expired before, some of them will expire today, and some of them will expire in future. So finding the minimum or the maximum for the expiration date does not make much sense. So we gave partial credit for that if the operations are correct. But what we are looking for is actually much more simpler. In question number 7, we are trying to find the minimum or maximum. So in these questions with relational algebra, you should have seen some examples in the class. And one common thing that people are trying to do is they are making some selection and saying that, okay, for date of, it is going to be equal to minimum or maximum of the date of, which we do not accept for relational algebra. In SQL, yes, you can use functions, but in relational algebra, we are not using the functions. So in some notations in the web, there are such usage, but we want you to use the things that we have seen in the lecture. And in the lecture, to find the minimum or the maximum, what we need to do is first the Cartesian product. And according to that Cartesian product, actually Cartesian product, we are making this cross product, or with the same name, we are doing it on the same table. Therefore we need to give different names to the different instances of these tables. And then on one side we are going to get the ones that are higher than the other side. So for example, in S1 and S2 case, so first of all, the oldest supplier, we are also saying that it is the smallest date of foundation. So we are interested in finding the smallest one, and the smallest one is going to be actually the one that is not the oldest. So we are first finding the ones that are older than at least one other entry of this table. And for this part, one of the important things is that, so the higher side is S1 and we are projecting the S1 side, and these should be compatible. So in order to get the difference for not oldest, it is the SIDs. So on the left side, I need the SIDs as well. I get the difference, set difference operation. And since I get rid of the ones that are not the oldest, the remaining ones would be the oldest. So it could be multiple things, right? With the same smallest state of foundation, there could be multiple oldest suppliers, or it could be just one. It doesn't matter as long as we do these operations right. And then, since I need the S name and the city information, I still need to join it with the supplier table, because for now, since I projected SID, I just have SID. So through SID, if you look at the supplier table, in supplier table, SID is the primary key. So I can join these tables as well. And since the joins are trivial, I do not need to specify what I'm joining. So in some cases, if the attribute names are different, etc., actually some people are even in that case doing it. But for the join conditions, you might write it like supplier.sid. It is going to be equal to the SID that is coming from this right hand side, etc. So no need to do that if the join operations are trivial, meaning that the attribute names are the same and the two tables that you are joining are related. So with question number 8, some people did the mistake that, so the question says find the name of the suppliers that sell products from all categories. So let's say I have some supplier. This supplier is going to sell milk and it is from the category dairy, for example. And it also sells, let's say, book, and this could be from the school category. So we have a bunch of categories in the category table. So we need the division operation. If you did the division operation on some tables, we gave partial credit. But what you are dividing by should be the categories. And on the left side, for the projection, I need SID and CID. So for CIDs, if I'm dividing by the CIDs, the remaining thing is going to be the SIDs, and then I join similarly to the last question with the supplier table to get the S name. And with the division operation, without the division operation, we cannot do this question. So remember, with division operation, if I have, let's say, these are some suppliers, let's say SIDs 1, 2, 3, and maybe I can make it a little larger. So let's say these are my suppliers, SIDs. For 1, let's say this is selling from category A, category B. So 2 is selling from A, B, and C. And let's say 3 is selling from C only. And if my categories are, so these are the CIDs after I join them. So I join sold by with in category and I project SID and CID, and these are my values. And from the CID of the category table, let's say I have A, B, and C. So if I make a if I make a division operation in here, what it means is that I need the SID that matches with all 3 of these categories. So do I get SID 1? It is matching with A and B, but it is not matching with C. Do I get SID 2? Yes, it matches with A, with B, and with C. So therefore I get 2. This supplier is selling some product from all categories. So it can sell multiple products as well. So it can also say to a multiple times. Since I'm just projecting these values, this will be like disregarded. But the important thing is that I need to divide by the category, because let's say in some case I also have an additional category. Let's say this is the computer category, but let's say nobody is selling from the computer category. So let's say nobody is selling any product from the computer category. Then the result of these queries should be null. It should return nothing, because nobody is selling from all categories, because nobody is selling from the computer category. So in that case, some people were, instead of category, writing here the sold by, but it is not enough. So in those cases you got partial credit from this question. This should be divided by the category. In question number 9, it was a basic one again, but this was again important. Some people, a couple of them, used the and sign. The city cannot be equal to Ankara and Istanbul at the same time. So this is very crucial thing, and in the exams as well, be careful about this. This is very basic mistake, but if you do that, you show that you are not considering what these symbols are meaning. And one other problem people are doing, this is like the first time in this term, they are saying, okay, city equals Ankara, comma, Istanbul. So how to combine these two? So you are giving a list of values, but if you do not specify how to combine them, so even if you write or and, this is still something you can write if you don't remember the signs. We accept that. But if you are not writing something, if this is a list of values, how to approach them? So that is some question. So you need to specify whether which logical operator that you are using. So for the last one, the important part was that this is again finding about the minimum or the maximum. So we need to use two different instances of the same table, make the cross product, and then we need to get the subtraction from the whole set. And the important part is that we need to do it for some subset of our values. So we are not interested in the most expensive product. So some people were first finding the most expensive product, and then they were joining, or they were looking at the intersection with the toy and other suppliers and categories. So what we need to do first is to first find the products that are in toy category and that are supplied by the other at the same time. So you can also use some intersection here, that's not a problem, but using the join operations are more straightforward. Then for these, after this part, we are giving two instances of the same table. So some people were choosing one of them at the first stage, but then instead of finding the toy category here, they were making the Cartesian product, getting the subset difference, and then in here somewhere they were making the selection, which is not correct. Again, we gave partial credit for that, but you need to first find this subset. So I have some products, and within those products I should find the most expensive one. Otherwise, if you get a bigger subset without saying toy, let's say this is all the other products, but there are some other kinds of products in here as well, in different categories. If I find the most expensive one first, then this most expensive one might not be a toy. It could be, for example, from some other category. Then if I try to limit that, if I say, okay, now I just have one value for the most expensive one, then let's get rid of the ones that are not toys, then I could get again nothing as well. So that was also an important part. So we need to then make the Cartesian product and get the difference from this whole set. And for this minimum and maximum questions, there is also one more solution. So instead of, for example, in here we are finding the max, right? And in here what we can say is, okay, let me try to write it. So in here we are saying, okay, A1 price should be less than A2 dot price from our Cartesian product, and we are projecting from A1 side, A1 dot PID. This is done to find the maximum one. What we can do instead is, instead of saying, okay, I get the A1 side, I could get A2 side, A2.PID, and these are going to be the ones that are higher than somebody. And in this case, I also need to include the equals operation. So it is going to be A1.price less than or equal to A2.price. And I'm projecting A2.PID. And then I can, for this part, let's say this is some K. I gave the name K to this part. Then I can say K is going to be divided by the PIDs from the same table. So with division as well, we can find the minimum or maximum. But in that case, the part that we project is going to change. So that's what I'm trying to say. One approach with the red one, or in the given part, is to find prices that are dominated by some other price. Prices that are not the most expensive one. We can find them, and when we subtract them from the whole set for the adorators, again, this is not going to be all the products, or this is not the sold by table. This is the subset that we find by adorators. And then the remaining ones will be the most expensive ones. The other approach is going to be finding the ones that are higher than at least somebody. And for this one, the most expensive one is going to be higher than all other remaining prices. So since we include the equal sign, it is going to be less than or equal to from itself as well. So for some value, maybe let me just write it quickly. Let's say these are our prices, and we make the Cartesian product. So we get every entry matched with every other entry. Sorry for the writing. So with the blue one, what we are doing is, on the right side, if it is higher than or equal to the left side, we are getting it. So this I get, these I get, and these three I get. Then if I divide it by the same table for the PIDs, that same table is 1, 2, 3. And if I divide by 1, 2, 3 on the right side, so these should actually be divided by, so I need to divide it by for the left side, right? While dividing it, I divide them by PID, and this should be A1 side. Yes, I'm getting it from A1 side, and for the A1 side, I'm dividing them. So if I on the A1 side have 1, 2, 3 matched with 3, so this is my A1 table. On the left side I have A1, on the right side I have A2, and for each of my entries in A1, on the other side 3 is matching, I will get 3. With the other approach, with the red approach, what we are getting is on the A1 side we are getting the entries, and since we were saying strictly less than, what we get is going to be these. So what I will get is going to be this one and these ones. And if I again project for the A1 side 1, 2 and 1, I have the 1 and 2 entries. And if I subtract them from the whole set, if I subtract them from this, what I get is going to be the maximum one. So again, this is from the lecture, but since some people have trouble, this was to remind it kind of unofficially. But these were the common problems that you have for the homework 1.